Hello everyone, welcome to this video. So in this video, we are going to talk about one very important concept that is called silver score. So we'll first see what is silver score, then we'll see what is the formula of silver score, then we will see how to implement a silver score using your Scikit-learn library, and then we'll see how to build scratch code to get the silver score. So there will be four steps we are going to discuss here. Okay. So Silhouette score, right? Silhouette score. So basically, Silhouette score is a number. Okay. So let me write here. Silhouette score. Okay. Silver score is a number that tells you how each point fits into a cluster compared to compared to other clusters. So if there is a point, how it fits to this cluster if compared to the other clusters. It helps you to evaluate evaluate the quality of a clustering. It is very important, right? Because if you build a cluster using maybe k-mean clustering, hierarchical clustering, db scan, but if you are not sure which cluster is much better, if you want to compare, so in that case you can calculate a silhouette score, and it will guide you, it will give you the direction that okay, this clustering is making more sense for a data. So that's why silhouette score is very important. If you see, so I think you believe you are able to understand what is silhouette score. Silhouette score nothing but just a number that tells you how each point fits into the cluster compared to the other cluster. It helps you to evaluate the quality of a clustering. So let me write here the formula of a silhouette score. That is nothing but bi minus ai divided by max value of either bi comma ai. So you have to take what is the maximum, either bi or ai. Always remember, if your ai is greater than bi, in that case your clustering is not working, you're getting a negative silhouette score. It means it's not fitting, maybe data points assigning to a wrong cluster. Okay, so let me explain you the meaning of ai and bi first. Suppose you have a cluster, okay, and there is a three cluster here. In the clustering technique, maybe three clusters are there. Okay, here you have a data point. Let's, for explaining purpose, let's take only two feature 1, feature 2, and these are the value. Okay, and because you run the clustering, you have the assigned cluster for each sample. So maybe this sample is assigning to the zeroth cluster. This is zeroth. This is for the second cluster, and this is assigning to first. This again assigning to zero. This again is 0. This is for, this is 2, like this. There are some number more samples. So this is your cluster. Okay, because when you do the clustering, your end goal is to assigning each sample to a cluster. Now what is ai? Ai is, if you take, so basically when you calculate security score, we'll do for each sample. Suppose you are doing the first sample, I is equal to 1. So what you will do, for I is equal to 1, you will take any point, and you know what that point is. That point is this, because I is equal to 1. This is coming to the zeroth cluster. That's why I put here in the zeroth cluster. Okay. So what we do, we calculate distance inside this cluster from each point. Suppose in this data there are some points. Here is also some points. Here is also some points. This point means the sample, right? So this is the first sample. As equal to 1, this is the first sample. What I will do, I will calculate distance from each point inside the cluster. Okay, and then what I will do, I will do the average, mean of the distance, and that is called what, ai. So basically a1, why a1, I is equal to 1. Then what is b1? Now again I will calculate distance from this point to each point outside the cluster. So basically the nearest clusters, these are the clusters. So I will take the distance and then I will do the average of all this. This is called B1. So here for this points I will have A1 and B1. So using this formula I will get S1. Okay. Similarly, I will do for this point. Now this will be here. I will calculate inside this. So basically, A distance is inside the cluster. B distance is outside the cluster. So basically, other cluster, right? And then we will get the S1. So like this, we'll first calculate S1, then S2 till Sn. And then we'll do the average of all the silhouette score. This will become the final silhouette score. I believe now we are able to understand theoretically. Okay. So let me re-explain it again. Silhouette score just a number that tells you how each points fit into the cluster compared to other clusters. It help you basically to evaluate the quality of a clustering. And you know the silhouette score formula, and now you know how it will calculating. You are picking the each point, going inside the cluster, calculating the distance, that is A, and then we're calculating distance from other clusters called B. Then we put the formula values here. You'll get the S1, then you'll get the S2, S3, S4, like Sn, and then you're just getting the average, that is become your final silhouette score. Now let me jump to the silhouette here notebook, my notebook, and let's go through one data. So here I have one data. So this is 100 sample in the data. Here you can see. Now let's calculate the, here I'm just using the LO method to get the how many number of cluster we needed. So one thing, in my previous videos I already discussed what is clustering, what is k-mean clustering, how k-mean clustering works. I did this through Scratch, through Scikit-learn. Then we also explained what is elbow method, and using elbow method how can we decide how many clusters are needed. And today video we're talking about silhouette score. So anyway, so let me show this. So basically these are the clusters. So we finalize the cluster. There are four clusters, and these are the cluster center point of the cluster, and we already finalized the cluster, and we saved this into the R. So basically R has all the labels for each point. So if you see the length of the R, it will be 100, right? Because there's 100 sample in the data. So here you can see there will be 100 sample. So if these are the formula I discussed already. If you want to calculate silver score through the library, what you have to do, you have to just pass from a calendar matrix import silver score, passing the data and passing the your cluster. So we saved into the R, and then if you run it, you will get the 0.36 value. Now if you want, we can do same thing using the scratch code also. So here if you can see, you can write the scratch code, and you'll see it, the value will be similar, 0.3604, 0.3604, right? Now let me explain you how I'm doing this. So I already explained you theoretically here how it is working. Now I'm going to explain you. So first what I did, I have a data. Okay. So if there is a zeroth sample, first sample, second sample, and there will be data point. So this totally 100 sample in the data. So what I'm doing, I'm first calculating a distance matrix for each point to each point. So there will be 100 row and 100 column. Why? If I'm taking zeroth row, okay, and calculating distance with zeroth row, first row, second row till 100th row. So here is the distance matrix where value will be 0 to 0 will be 0, 0 to 1 maybe some values, because if you come calculate distance for a same point, will get the 0 value. Then I have the first sample calculating like this, then I will get 0 because distance of same point will be 0, and then I will get the value. So here I calculated this matrix first. This is 100 plus 100. So let me write here, let me show you. So here I calculated a pairwise distance. This is just a formula. If you pass your data, it will automatically calculate the distance of each point. So here you will say I'm getting 100 cross 100 because there will be 100 samples, so it's calculating distance between 100 and 100. If you see the first zeroth row and zeroth column, so here you can see that's why I'm getting 0. Why I'm getting 0? Because the zeroth row and zeroth column. Here first row and zeroth not first column we are getting 0. Second row, second column we're getting 0 because If you calculate distance between the same point, you will always get 0. Okay, now what I'm doing, I'm writing a loop going inside the data. So how many this loop will go? 100 times. Why? Because the number of sample in the data is 100. So I'm writing a loop on the length. So it will go 100 times. Then I getting the current cluster. So R, I already know that. No? We already know that. No? Because we saved our cluster in R. So this is the R. So if I write R of 0, so I'll get the zeroth value, right? Zeroth value. Why zeroth value? Because first time R will be I. Let's write a break here. So let's do the first sample only. Let's run this code for first sample. So if you see the cluster center will be what? Let me show this. So cluster center will be what? The 0. Why? Because the first value of R is 0. So that's why cluster center will also 0. And we know this, no? Because if you write here R, so I think first cluster is 0 only. Okay. So that's why we are getting 0. Correct. Now what I'm trying to do, I will just trying to get all the points, all the index where 0 is there. Like 0 is here, index 0, 1, 2, 3, 4, 5, 6. Then this. Let's calculate that distance. But when you are calculating the distance, sorry, all the index, let me explain you why I'm doing this. Because for I have to calculate distance inside the what? Inside the cluster. So R is basically like R is saying 0, then 1, maybe then 0, then 0, then 1. So these are the index. Now this sample will going to the same cluster. So if I want to get the index will be what? Index will be 0, then 2, then 3. Why? Because this index will actually, if you get the same index from the data, that sample will be assigning to the 0 cluster, right? You get my point? Because see, if this is my data, so the first sample is going to 0. Why 0? Because here it's 0, right? So that's why. So what I did, I will calculate the index. So when we calculating we will get the index, then we are removing that index from here, which is what? That was the sample. Why? Because when you're calculating the distance from a sample, you know, this value is always 0, right? So if you that's why you remove it. You're able to understand. If you are taking 0, so suppose here, let me explain here. Maybe you came to know that, if you came to know that in this data, these are the point is coming into the 0 sample. This is the point is coming into 0 sample. And this is 0, this is 10, this is maybe 22. So and I'm looking for this sample, this point. So I have to calculate distance from here to here. If you calculate distance between this, you will get always 0. So you can remove this, right? So that's why what we do, we remove this one. You here you can see, that's why we are removing that I, which is the sample we are looking for. So that's why if I run this, let me show you. If you run this and let's see this in cluster, let me show what will happen here. Let me print you in cluster here. So see this in cluster is we removed 0. See 0th sample is in the same cluster, but still we removed is why we removed this. We removed this because we are taking that we are calculating Silverty score for that label only, that 0 sample only. That's why I removed it. And then I go to the pair matrix. I will then after what I will do, I will go to the pair matrix, take the 0th row and all the column which has the index. Why? Because you already calculated distance between each point. So there is no need to calculate distance. We already saved here in D. So we are taking that 0th row and taking all the column which has the index. So I will have the distance, that is AI, and now I will just take the mean average. So I will have the A1. This AI is nothing but your A1. Similarly, I will do for BI. So in the case of BI, what we will do, we will take other cluster. I will see, I'm writing here np.unique r. So this will basically, there are 4 clusters. So this will loop go 4 times. But whenever this cluster is same is equal to the cluster current cluster, because here we saved the cluster. In that case, just continue. Continue means what? It will not going to the next. It will not going to run all these. Just go again to the loop. And so whenever this cluster ID is equal to the current cluster, it means we want to calculate distance from the other cluster. That's why we are just removing whenever the same cluster. And then we are getting the minimum average value. Here calculate the average, and then we calculate the stability score. This is the value of S1. Similarly, we calculate for S2, S3, S4, and then we will just do the average. For that, we just let me write here break. So here it is the sampling. Okay. So if you want to see this again, if you want to see this all these things again, what will happen? Let me show you. So last time, here your R is okay. This is the R, right? So if you run this, so the current cluster, this one Ri, the I is the last value. So I is equal to 99. So here you can see we got the 2. So actually the 99 cluster will be, data point will be this in the second cluster. So that's why current cluster is 2. Now we are getting this 55 like this. So if you see this 55 and all, whenever 2 is there, we are taking and we are removing. Here you can see 99 is not there. See this. Why 99 is not there? Because we are last is sample will be 99. Na? So it's I show you for first also, no? So we are removing 0. Here we are removing 99. Why? Because we are calculating silver score for that same that same uh, uh, mm, sample, no? That is 99th sample. That's why we removed here. Na? Here you are removing this, no? If in cluster is equal to y, just remove that one. Okay, and then we're calculating, and then we're just saving everything. Then we're getting the silver score. So in this video, what we discuss what is Silverty score, then we discuss the formula, then we discuss using sklearn how to calculate the Silverty score, and then we discuss if you want to implement your formula with Python, how can you do and how can you get the Silverty score. So now I believe you are able to understand the full process, how we are able to get the Silverty score. And it's very, very important to understand the Silverty score value because it will, it will giving you direction whether your clustering techniques is working fine or not, right? So thank you so much for watching this. If this video making sense to you, please like and subscribe my channel. Thank you so much. Thank you.